All right, hello everyone, and welcome to another workshop in the Polaris Hackathon series. Today we have a special workshop on smart contract programming with Go. With us is Roman Khimov, the principal software engineer at Neo SPCC. Tell us a little bit about yourself and your work, Roman.
Well, I've joined Neo SPCC back in 2019, and the idea back then was to we had some issues with the C# node. It didn't really fit into our infrastructure that we had. So the idea was to quickly cook up a node in Go and then move on to something else. But for some reason, the project is still there, and we are working on it. And it takes it develops and it grows over time, consuming our time. So basically I'm leading this project since then, and we are developing not just Node but all the other components of the ecosystem that are necessary for a complete solution. So yeah, that's what we're doing.
Right, and you are part of the group that has developed NeoFS, the most powerful decentralized file storage solution on the planet. And are you ready to start your presentation, Roman?
Oh yeah, I think so. Today we're going to be discussing smart contract development because in some ways NeoFS itself is a DApp built on top of Neo, and so it makes it kind of an interesting twist because it's not just the NeoFS that we have in Neo, but it's also Neo that we have in the NeoFS. So yeah.
Fantastic. Okay, so when you're ready, start your stream and we will watch your presentation.
Okay, so does it look right?
Looks good to me. If anybody else wants to answer in the chat, let us know if you're having problems or something. But right now I can hear your voice and I can see your screen just fine.
Okay, good. So let me first tell you a little bit about what NeoGo is and what are the specifics of the project, because even though today we're going to be talking about contract development in Go language, the NeoGo project itself is a little more than that. As I have already said, it's a full node implementation. First of all, that's how we got the project started in the first place. And then it grew over time and got a full consensus node implementation, RPC functionality, CLI, and everything else to make it a real substitute of it basically can work as a one-stop shop for everything you need for developing DApps for Neo. You can run a node, you can manage your wallets there. I mean, NEP6 wallets. You can write backend code using our RPC and some extensions, and you can also develop, of course, contracts in Go that you can then deploy using the same tooling that we provide, and without really going into anywhere else. I guess the only thing that we don't cover is something for front end that you will use something else for, and another thing is probably debugging, but that's going to be covered a little bit later. So speaking of contracts and workshop, we have a repository for the NeoGo Smart Contract Workshop that's been there for something like 2 years, I think. It was first started when we were presenting our technology to the students way back when, and it was based on the Neo legacy, what's now known as Neo legacy code. But of course, it then evolved, and the purpose of this workshop was to show students what a blockchain is, how it works, how it operates, how to make some basic steps with it. And it has some contracts that are pretty, simple, just to show some basic things and to introduce them one after another. I mean, one concept after another. I think in general, the audience, we have today have a bit better understanding of what a blockchain is and how it operates. So we will jump through some steps of it to show some Go specifics of the platform that we provide and how it operates and how it differs from the C# environment that many are used to. And yeah, so what we're gonna do is we're gonna take our node and I guess for the first example, I will just show how to work with the new Go node itself. So So speaking of about the node, you can take the binary from our page. We have releases, and we have binaries built for Linux and Windows. Both platforms are fully supported now, so you can grab whatever fits you and use it. The release that we have now is 3.1.0 compatible, and of course we are working on the changes needed to support 3.2.0 functionality that's going to be released somewhere along the line of when the 3.2.0 itself is going to be released. So, but I'm going to use the development environment I've got, the local repository that I have. I have some version there that's not stable, but that I think makes it a little more fun. So, if we are looking at the workshop that we are presenting, we are running it using our node. So we don't run C# version of the node. For it, we use Neo Go. The workshop itself is written so that it uses the 4-node setup of the Neo Go private network. But I think to simplify some things, we will use the single node setup here, because 4-node just will take a bit more time to do some other things with asset transfer. So, but actually both are supported, and we have predefined configurations to work in a 4-node private network and a single node private network. It all is supported. So if we do this, make env single that runs a single node, single instance of the node, the consensus node, and that's all the network we have. It runs with Docker. So if we are looking at the logs from this node, we can see that it works. It basically outputs a block every second, and that's a Neo Go node running a private network. So what we're going to do next is we will take an example contract that we have and see how it looks and try to do something with it. We will jump right to the second contract because the first one is simple hello world, and it's not very interesting. So the second contract that we have is the one that uses storage for to show how the storage works. It's pretty simple. It just it has a deploy function that will be run during the contract deployment or update, but this contract doesn't have any update functionality. And it has just one method that you can run to basically get and the value from the storage, increment it, store it again, and that's it, producing some runtime notifications along the way, runtime events. A contract for Neo Go is always accompanied by the YAML configuration file. That's probably one of the differences between the way Neo Go works and some other environments work, like the C#. They use annotations a lot in the C# code to provide additional metadata for the manifest file that is generated during the compilation, but we don't really have annotations in Go, and we didn't want to invent any special syntax for comments. So all of the contract's metadata is stored in the YAML file that's needed for the contract. In this case, what we have here is just the name, list of supported standards that is empty here. There are no standards that we support in this contract, and the list of events. We have one event defined here with the name info and one parameter. As you can see, that's what we use for the notifications. So, of course, YAML file can have way more data than that, and we're gonna see that in some in the contracts we will look through subsequently. But that's what we have for this contract. So to compile this contract, we're gonna do this. Here we go, contract. By the way, that's the CLI we have. The CLI itself, it also implements the node, it implements all the functionality we have. But to compile the contract, we have this functions, compile. You can always take a look at the help, and as you can see, there is quite a lot of written there if you're missing something. So the unit of compilation for Neo Go, and as it usually in Go, is a package. So some of our old examples used direct file specification like this one, but it still works today, but the compiler itself will compile the whole package anyway, and the package basically is a directory. So that's the way Go works in general, compiling code in packages rather than files, and that's the way Neo Go is also. So we will give it the configuration file that we have. Storage. And now we're gonna produce some output out of it. That's gonna be F and the manifest file. Something like this. Yeah, so it works, and that's what we have. These are the output files we've got. It's a pretty standard NEF or NEF file that follows the property standard. that Neo uses for its executables. That's NEP 16. Yeah, NEP 16. And the manifest file that's conforming to NEP 15. That's what the manifest basically describes the methods that the executable provides. So just to show you something, we can actually take a look at the NEF file to see what's the code in there. And it's probably, yeah, it also wants the manifest. So if you take a look at this, and that's the Neo VM code generated for our contract. Someone with experience looking at this code can tell that this is the start of the function. It probably ends somewhere here, and this is the other function. So we have two functions there, and that's the code. So to deploy our contract, we're gonna use, and again, to show you some of the functions that we have, we're gonna use another account that we will create wallet for. And that's gonna look like this. So with this, we create a wallet. It's a standard NEP6 wallet, again, following NEP standards. Every other tool in the Neo ecosystem is supposed to understand it as well and be compatible with it. So that's what we have also. Now we can, as we have started our private network, from the Genesis block, we need to transfer some gas to our account. So yeah, it's explained in this way in the workshop, and we will do it here. Wallet again, just to show you the possibilities. There's quite a number of commands there. 17 commands, and we want to transfer again, just to take a look. Take this wallet that we have, and we want to use our node. Oh, okay, that's not the correct wallet. So as we are transferring from the Genesis account, we need to use the wallet of the key owner. Yeah, it's gonna be the right one. To the address that we've got there. And that's okay. Okay, now that's because we haven't specified the address, and the transfer command just used the default address in the wallet. And frankly, I don't remember which is the multi-signature address, so well, let's find out. So in this wallet we have several accounts, and the right one, if I remember correctly, is this. We'll add to the parameters. And yeah, so as you can see, the CLI asks for confirmation because we are going to be not just transferring gas, but also spending some gas for fees. If we answer yes, there's going to be, this interesting side effect because by the time, but while we were thinking the prepared transaction already expired, but that's okay. That's kind of expected. Yeah. So now we have our transaction sent to the consensus node, and given that we have 1 second block time, which is ticking here. Where is it? Okay, doesn't really matter. But I think it's already accepted, and to make sure that that's the case, we can ask our node about this transaction. Yeah, as we can see, we can also make some verbose output just to see some additional metadata. So the account now has some gas, and we can deploy. Contract deploy. What do we have there? We have parameters for the wallet, for the RPC node. And also, speaking about our CLI, I should add that it's made in the way that internally it works via RPC channel. So unlike in the Neo CLI, to be able to do something, you have to run a node, and then you get this CLI, and you are able to do something with it, like transfer tokens, like deploying contracts and things like that. That's the C# way of doing things. But we do it a little bit differently in that the CLI itself can connect to any RPC node and just get the data it needs from it and create transaction or do whatever action is required, and then send it via the same RPC and be done. So it technically doesn't require you running a node if you are working with a mainnet or testnet or any public network. So I think it can be pretty convenient in some scenarios. So now we're going to be deploying, and to deploy we need our NEF file and the manifest file. Manifest JSON. I think that okay, that's a table. And we have the same thing. Yeah. So we have a deployment transaction, and we have a contract hash as a result of it. And we can check the status of this transaction. It went fine. So now we can invoke our contract, and the way we do it in NeoGo is again using the CLI that we've got. We have the main method. One thing that should be noted about the names of the exported methods, if anyone coded in Go, you probably know that for a function to be exported from the package, it has to be named with a capital character and starting with an uppercase. But if your function is named like this, it won't be exported. The same rule is applied to the Go code that's compiled by NeoGo, but there is there is one little nuance that you need to know about. For any name that is exported, we lowercase the first letter of it, because to be compatible with the naming scheme that is used for standards like NEP 17 or NEP 11, we have to we need to have methods like transfer that is named like this, but we won't export it if it's named like this. So you define the method named transfer, and when it gets compiled, it's named transfer. So that's the way it works. It's just something that you need to know, because when we are going to be invoking this method, we are going to be calling it with the lowercase main. So to invoke it, we're going to do this contract. There are two modes of invocation that probably you have already seen in other from other languages workshops. The test invocation, and the invocation that does that creates a transaction that then is submitted to the blockchain. So a test invocation is basically just running the code on this server via RPC and getting the result, but not really changing anything. And if you're doing real invocation, you have a transaction created that will do something on the real chain. So we probably can start with the test invocation just to see how it goes. And it has a pretty complex syntax for its parameters, because here we will pass some arguments to the invocation, and there are a lot of options that's basically provided by the protocol itself about what can be passed to the invoked function. So there are a lot of options and possibilities there. I won't go through all of it. That's not the point right now. What we care about most at the moment is that we need to provide the script hash, the method name. Our method doesn't have any arguments, so we can skip it. The contract is this one, and the RPC node is the same as we used previously. Main. Yeah. So that's the test invocation that we just made. We can see that there is something returned on the stack from it, and we have a number of notifications generated. These notifications are actually generated by these calls to runtime notify. And if we are to look at them, that's the ones defined in the contract. So we can make a real invocation. But to make a real invocation, we of course need some wallet, because someone has to pay for it. And so that's going to be our, yeah, this account with this fee, yeah. And now we'll take a look at what happened to this transaction. As we can see, it succeeded as we expected it to. So I think I should probably tell a bit more about the way we write these contracts. As you can probably see, we have a number of some packages imported there, and these are the so-called interop packages. We have runtime and the storage imported. So the storage package provides functions dealing with the contract storage, pretty obvious, and runtime. In this case, we just use notify, but you can also log and do some other things. All of these packages are documented using the standard Go way of documenting on package Go dev. So you can always go there and see what's provided. And these are the packages that are used to write contracts in Go, because that's the way we export, for example, not just the things provided by syscalls, like, let's see, a runtime package. As you can see, these are the syscalls that are provided by the Neo platform, and it basically, you have the same functions any other language. It's just that the way they are represented in Go is with this package, like log, notify, platform, and other functions. As for native contracts that our Neo platform also has, we are also providing some wrappers for them, and they are represented in the native sub package. I think pretty obvious, like for the standard lib that's called std-lib native contract, we have this std package and provides everything you can expect from it. So all of the functionality is there, and it can be used, and there are examples for them. It's like if you want to access the gas contract, that's the interface for it. Okay. So we have just built and deployed our contract, and basically, given that we have the ability to test Invoke and Invoke contracts and have these private networks, that creates a complete environment to do your development. And I will probably I can probably say that the most of the NeoFS code is written in a similar fashion, in that we just do these invocations and see how things go. But at the same time, I can probably say that many people expect a bit more friendly environments, maybe, because as you have noticed, I'm using Emacs to write code, and I guess it's out of fashion for quite some time already, along with VI and other CLI editors. I know some people in an SPC use Golang, but for contract development, we also have an ability to use Visual Studio and be able to interoperate with the debugger that is developed in the Neo project, and you probably is well known. So to do that, you just need to compile package with an additional parameter. So if we were to take a look at it, yeah, that's the compilation string that we've used, and if we are to output the nef manifest, yeah, and we can also output the debug information. So we have a whole set of outputs there now, and we run the Visual Studio and the other screen. Yeah, I think this interface looks a bit more familiar to people developing smart contracts in other languages like Python or Java or whatever else, C#. We can use a standard yeah, if I remember correctly, just create a standard configuration for it, and then try to deploy our contract using deploy. And we'll choose Genesis storage. So it's the same contract, the same nef file, but now we are deploying it using the Neo Express. So behind the scenes, it's running a C# node now, and since we are compatible, I mean the NeoGo node and C# node, it all works fine. So we have this deployment transaction now. We can invoke it the way it's invoked in Visual Studio Code. Storage contract, the main function. Run it. Yep, and we have a transaction there. It works. Will probably take some time. Yeah, it's confirmed now. Yeah, so we see the same notifications as we've seen with Go. And probably the most interesting thing is that we can now debug it, because that's really changes the experience significantly from the way we develop our contracts, in that you can use all of the features the Neo debugger has and step through notification. Yeah, that's our contract. As you have seen, we for previous lines, we basically jumped to the internals of these interrupt implementations that I think we will probably tune in our debug data. But anyway, you can use the Neo debugger with Neo debugger with NeoGo compiler to debug your Go code, just like any other code written for the Neo platform. And I think this integration actually provides more options for users and for developers that are writing code, and in general it's a very nice option to have, because the debugger itself, of course, is awesome. Know that. So yeah, of course I wanted to show you this integration part. And now is we probably don't have a lot more time. I will just quickly walk through the examples we have also in our repository for everyone to look at and see some contracts written in Go. So we of course have these examples are the main repository, so it's not a workshop repository. The workshop has only 3 contracts and they're pretty basic ones. The examples we have in the main repository in some ways are more complex and they showcase more features and implement some standards. Like we have the token example, that's a NEP 17 token implementation. Yeah, that's NEP 17 with all the appropriate methods. Internally, it uses a sub package, so you can also see that you can use the standard Go packaging, package imports for your code, so you can structure it in several packages and use that. That's the internal package that we have. And if you take a look at the YAML file for it, it's a bit more involved than the previous one. We have additional data for source URL. We have supported standards, that's NEP 17 here. And we have safe methods defined that have to be defined as safe for the NEP 17 compatibility. There is a standard transfer event, and there is also permission to call on NEP 17 payment method on any other contract, because for any NEP 17 transfer you need to, if it's done for the contract address, you need to call it on NEP 17 payment. So the contract needs to have a permission for it. There is, by the way, there is an interesting compiler feature. I probably can show you right now. This example, it's there, token, yeah. So if I'm to compile it, token configuration for it, and we will help it manifest. Yeah, it works. But now what I'm gonna do is, oh, by the way, I don't think we need node anymore. Yeah. So what I'm gonna do is now I'm going to intentionally make some changes for it. Let's say I will do it this way. Now, as you have seen, I have just renamed one of the methods that is defined as safe method, and the compiler obviously sees that the method that is defined as safe is missing from the actual code, so it warns about that. But that's probably not the most interesting thing. Probably the more interesting thing is that we can also check for standard compliance in our compiler, because we have the supported standard defined, and well, this balance off is already written there, and we kind of can expect that it's checked. We can also check for standard methods that are that should be present in every NEP17 contract. So if I'm gonna mangle the name of the transfer method, what's gonna happen? Yeah. What's gonna happen is this: the compiler checks for NEP17 compatibility and actually just errors out unless you tell it to forget about this error. It's possible to disable this check, but by default it's enabled. And compiler checks your compatibility if you have NEP17 or NEP11 compatibility defined. So that, I think, is a pretty interesting feature that we have in the compiler. And another thing that I wanted to show you is testing, because you can use Neo Debugger for your for contract debugging, and you can of course solve most of the problems that you have there, but at the same time I think you want to write some automated tests for your contract. At least most of the people do. And for this we have a package called Neo Test. So what Neo Test is, we use it in one of our example contracts. That's NFT contract, that is NEP11 contract, that defines a Neo name service. You can probably, take a look at it here. But it also has some tests written for it using this testing framework, as we call it. So the tests are written in Go. They use the Neo test package that also has the documentation available at package Go dev, as all of the other packages do. And the tests are written as regular Go tests, Go unit tests, the way you write it for any other Go code. And it basically creates a new chain while running for every test, then compiles the contract that we have there, deploys it to the chain, and then invokes it in the way we need, checking for some values, seeing how it errors out or succeeds. So all of this is also available for anyone trying to write contracts in Go, and actually it's used quite extensively in the Neo FS contracts. So it's there. Also, while we still have time, I guess, I think one thing to know about contract development and the tooling provided by NeoGo is that we are able to create contract bindings or contract wrappers for the contracts deployed to the network or basically mainnet or testnet contracts that are written in, that can be written in any language, irrespective of the original compiler. The functionality is provided in CLI. Generate. So the idea is pretty simple. Every contract deployed to the network has a NEF file and the manifest. The manifest is a public standard that is NEP 15. Yeah, NEP 15. And this manifest can be used to generate wrapper code to be used by other contracts. So we will take probably the manifest that we just compiled. Oh, yeah. And then we need hash of the contract, there. And we're gonna output it to, does it work? Yeah. As you can see, this code generated for our storage contract that we have started with. It defines a hash in a format that can be used by other contracts, and it also creates this wrapper. So it's pretty interesting that using this wrapper you can then import it if you have it in some package into another contract, and then just if it's going to be imported like storage and add to the module, whatever that is, you can then write code like this one. It's just to show you how it will look. And it will invoke this wrapper and use more optimized way of calling methods of other contracts and basically just work. The reason that's important because for this contract it may be not so obvious why it's a good thing, but because the method itself is pretty simple. It doesn't have any parameters, it doesn't have any outputs, it just does something internally and exits. But for real contracts you will have some methods defined that accept parameters that do return something, and basically this wrapper provides you with a native interface to any contract that you need that's going to have proper number of parameters and proper type for the output that the function has. To compare that, if you don't use wrappers, and in some cases you can't use them because you have to call, let me find this code. For NEP 11 or NEP 17, you have to call these payment methods, and you don't know which contracts you're going to be calling, so the way the code looks there is a little bit different. Oh yeah, that's the way it is. Contract call, that's the generic method for contract calling, but using wrappers it will look a little bit different. It will look just like a regular package invocation Go, just look like a regular function invocation from the Go package. So that's the functionality that we have. Probably I should try it on some more complex example, like the one we've compiled. We've compiled token, yes, token.json. What's it gonna look like? Yeah. For example, that's basically the NEP 17 wrapper for the token contract that we have. So that's what we have for contract development, and I think I should probably mention some of the node features that are, and maybe not just the node. We also have, because as I have said, we basically have all the infrastructure needed. We've got an RPC client there. RPC client, yes. That you can use to write some backend code, because the app is not just contracts, and you also have to have some backend that you need to have some tooling for. So what we have is this client package that you can use to connect to the RPC node and basically use all of the functionality provided by RPC nodes, and then some additional things that we have on top of it, because we're probably gonna be restructuring this API a bit in the future. Currently, it mixes some of the lower level functionality provided by RPC and some higher level stuff like this NEP11 functions you see, or NEP17 functions you can also see. We will probably restructure this a bit, but still it's there and available for you. And well, one additional feature that is tied to Neo Go. Yeah, I should also mention that these functions can use any RPC node that is available, whether it's C# or Go node, it doesn't really matter. But there are some things specific to Go and to Neo Go. That is the WebSocket client. So in Neo Go, we have in the node implementation, we have some extensions, and some of that extensions are probably interesting for the backend developers, because I should probably mention that Neo FS itself uses these extensions, and they were in some ways written to support these Neo FS development. So it's the WebSocket server itself, which basically provides the same functions that we have in the regular JSON provided by JSON RPC in a WebSocket wrapper, but it also has this notification subsystem. It allows you to subscribe for events on the node and do it remotely. So you have this NeoGo node. Any NeoGo node can provide this for you. You just connect to it with a WebSocket client, then use the API provided there to subscribe for some events like blocks, transactions, execution results, and especially for notifications that you probably care about most if you have some contracts deployed on the network. And then just get these events in a channel and react on it. That's the way it's supposed to work. It, of course, is documented, as you can see, and available to use, and is used by Neo FS. As for Neo FS, that also can be seen as an example of contracts, but I should probably say that these contracts are really advanced and probably shouldn't be looking at them if you are just starting your contract development, but at the same time they are open, available for anyone to see. And if you want to see some complex contracts written in Go using NeoGo deployed to NeoGo nodes, you can always do that just by looking at the NeoFS contract repository that is available on our GitHub. So I think probably that's all I wanted to tell today. So take NeoGo, use it for your contract developments for your node, for your consensus nodes, and for everything, because we've got all of the functions needed, and it can be used. Yeah, I think that's it for now. Maybe the questions.
Thank you very much for that informative presentation, Roman. And we will now open up the session to questions from the audience. If you have a question, please enter it in the devlog text channel, and we will pass it on to Roman. And while we're waiting for questions, Roman, I have some myself. First of all, would you mind telling users what it means for a method to be marked as safe?
Well, safe methods are basically methods that don't change state, that are not emitting any events and not doing anything to storage other than looking at it. It's mostly used by the methods like balance off in NEP17. So when you need to look at someone's balance, you don't do anything, you just read storage and return it from the function, and that's a perfect example of a safe method. So yeah, that's probably the definition of the safe method. And of course, for contract developer, it's important to mark methods that don't change storage as safe, because that allows for better checks in one of the things that is important probably is that you can always call these safe methods from other contract, unlike the methods that are change state. That's one of the things, the permission system that we have forces that. So having a method marked as safe is an important thing to have. And to probably have some examples of how it's used, you can always take a look at the NEP standards, NEP17 and NEP11. All of the methods that should be safe are defined as safe there. That's simple method, which is safe decimals, total supply balance of, as I've said. Yeah, that's what we have.
Okay, so is it fair to say that another way to put it is a safe method absolutely does not write to the blockchain?
Yeah, it doesn't write to the blockchain at all, and it also does not emit any events. That also is important. It doesn't. Maybe I could say that it doesn't. It probably won't be correct to say that it doesn't produce side effects, except the thing that it returns from the method itself. The return value is there for you, but other than that, it does nothing.
Okay, and remember, people, if you have a question, please enter it now into the devlog text channel. Another question I have is, I noticed that on NEP17 payment, that method was in the permissions block of the YAML file. Why and when do you have to do that?
In the permissions section, you have to specify any method that the contract is calling on other contracts. If you don't specify it, the system just won't allow you to do that. So you will deploy this contract, but once it will get to the call to the other contract, it will just fail. So this just has to be done for everything to work correctly. And yeah, as you have noticed, we have it defined, and not just like here on NEP11 payments. It's pretty simple, but similar. But also, for example, this hash. The hash is contract management's contract, and we have a method defined to update our contract. We also define it in our permission section to be able to do this update. Otherwise, we just won't be able to.
Excellent, thank you. Another question I have is at the start you mentioned that you have the option of specifying whether you want a single node, private instance, or if you want a four node. When would a developer actually need or want to use a four node?
To be fair, I don't think any regular developer wants to do that for contract development, because it only makes sense for us, probably it makes sense for us more if we are developing the node itself. And for us, it's important to see how it operates with multiple consensus nodes interacting, and how it operates when we have some number of committee members. So I think it's mostly relevant there, but for people that are writing smart contracts, I think single node environment is probably sufficient in 99% of the cases. It's hard for me to imagine why you want to run a four node scenario, but it's still there, it's available, and probably there is some historical connotation to it, because way back when we worked on a legacy, at some point in time we just didn't have the ability to run a single node environment. So of course there we just had this four node set up, just because that was the minimal number of nodes that we could have. But other than that, I think for most of the people it would be just a waste of resources.
Thank you. Also, when you were entering that transaction with the NeoGo client utility, it, you had a time expiration condition. And what I'm wondering about is, A, what is the default amount of time you have to enter that transaction? And can you change that time?
That's a pretty interesting thing. I don't think you will ever notice that on public networks, because there you have first of all 15 seconds block time, and then you have a number of consensus nodes. But it's related to the way the NeoGo client, I mean RPC client, operates and how it creates transactions for you. We usually make our transactions in such a way that we define their valid until block field to some not a very not a very large number from the current block. So the way we have it is we look at the number of consensus nodes on the network, and we expect our transaction to be settled in the number of blocks corresponding to the number of consensus nodes. What this gives to the user, probably operating not from the CLI itself, but creating these transactions programmatically, it creates a more predictable environment for them, because they can, based on this valid until block number that we know that by the time of this block, either transaction gets into the chain and it does what it does, or it never gets in. So we can set our expectations for this transaction and not wait for it for a day. That is the maximum increment for this valid until block, and just wait for the next 7 blocks. If it's there, then we are fine. If it's not, then we should do some fallback or whatever else is appropriate. And in this case, because of the single node setup and a 1 second block time, we have a situation where the valid until block setting is set to probably some 2 blocks away. And in this case, it means just that the transaction expires in just 2 seconds. So this creates this, again, you won't notice it if you're using RPC client and you create transactions programmatically, but in the CLI, yeah, it really it can be noticeable if you're just looking at these fees and thinking, should I spend this gas or not? I think we will probably tune that because it's a special case, obviously, when we have this single node for development and 1 second block time. But for mainnet and testnet, I don't think this will ever be noticed by anyone.
Excellent. Fantastic. Okay, so we're about to wrap this up. Is there anything else you wanted to tell people about, Roman? Do you have any interesting new features or plans or anything at all? Roman, are you muted?
Oh, yeah.
Okay, so I guess not. All right, everyone. Thank you very, very much for attending today's technical workshop. We really appreciate your time. For those of you in the Polaris Hackathon, good luck with your entry. My name is Robert Oshler, and see you next time. Goodbye, everyone.